Welcome to Chapter 2 Operators and Conditionals. Python supports all the standard arithmetic operators. Plus for addition, minus for subtraction, asterisk for multiplication, and / for division. Note that division always returns a float in Python 3. / is floor division, which rounds down to the nearest whole number. The percent sign is the modulo operator, it gives you the remainder after division. And * is the exponent operator, so 2 raised to the power of 8 equals 256. These operators follow the same order of operations as regular mathematics: brackets first, then exponents, then multiplication and division, then addition and subtraction. Let's watch arithmetic operators solve a real problem, calculating a discounted price with tax. First we multiply price by tax rate to get the tax amount. Then we add them for the total. We apply a 10% discount using multiplication. And finally subtract it. Notice the :2f in the f string, this formats the number to exactly 2 decimal places. This is a pattern you'll use constantly in financial calculations. Comparison operators compare two values and always return either true or false. Double equals checks if two values are equal. Note that single equals is for assignment, double equals is for comparison. Exclamation equals checks if they are not equal. Greater than, less than, greater than or equal to, and less than or equal to, these work just like in mathematics. These operators are the foundation of decision-making in Python. Logical operators let you combine multiple comparisons. The AND operator returns true only if both conditions are true. The OR operator returns true if at least one condition is true. The NOT operator flips the result, true becomes false and false becomes true. For example, age greater than or equal to 18 and has ID, both must be true to enter the club. Or, age less than 5 or age greater than 65, either condition allows a discount. You can chain these together to create very precise conditions. The IfElse statement is how Python makes decisions. It starts with the keyword if, followed by a condition and a colon. If the condition is true, Python runs the indented block below it. If it's false, Python checks the elif, short for else if. You can have as many elif clauses as you need. The final else clause catches everything that didn't match any condition. Indentation is critical in Python. The code inside each block must be indented consistently. Python uses indentation instead of curly braces to define code blocks. Watch how our grade calculator uses conditionals. The score is 85. Python checks the first condition: is 85 greater than or equal to 90? No. So it moves to the first elif: is 85 greater than or equal to 80? Yes. Python runs that block, sets grade to B and message to good job, then skips all remaining conditions. This is called short-circuit evaluation. Once Python finds a match, it stops checking. The F string at the end combines the grade and message into a clean output. You can nest if statements inside other if statements. This is called nesting. It's useful when you need to check multiple conditions in sequence, like first checking the username, then checking the password. But be careful not to nest too deeply, it makes code harder to read. Python also has a shortcut called the ternary operator, which packs an if-else into a single line. The syntax is, value if true, then condition, then else, then value if false. Use this for simple, readable one-liners, but stick to regular if-else for complex logic. Fantastic work completing Chapter 2. Here's your recap. Arithmetic operators let you do all kinds of math calculations. Comparison operators always return true or false. Logical operators, and, or, not combine conditions. The IfElse structure lets your program branch and make decisions. And the ternary operator gives you a clean one-line if-else. Remember, indentation defines blocks in Python. In Chapter 3, we'll learn about loops, which let you repeat actions automatically. See you there.